we must first build our foundations. It'll not only help you in clearing interviews, but also in making sound decisions in designing your application. If your why isn't clear, you'll have no idea what you're doing, and you'll blame it on Next.js by saying that it's an overrated piece of technology. That will only showcase your lack of knowledge. It's a foolproof recipe to amaze everyone with your impressive ignorance. So perfect your why, and your how will come naturally. Now let's time travel a bit to see how we were used to doing things before with different technologies. First, the vanilla approach: HTML, CSS, and JavaScript. Websites built using the web's fundamental elements, namely HTML, CSS, and JavaScript, function differently compared to the latest technologies. When a user visits such a website, their browser or the client sends a request to the server, which is another computer where the site is hosted, asking for the content to be displayed. Traditionally, for each of these requests, the server responds by sending 3 files: HTML, CSS, and JavaScript. Of course, only if JavaScript code is involved. The client browser receives these files and begins by analyzing the HTML file. Then, it applies the styles from the CSS file and implements any user interaction, such as event handlers or dynamic behavior specified in the JavaScript file on the web page. If the website has multiple pages, the client will send additional requests to the server for each page. And in each response, the server will again send 3 files containing the respective content needed to render each subsequent page. Well, what's the catch? Let's talk about processing, bandwidth, and load time. Most processing occurs on the client side, meaning the user's web browser is responsible for rendering the HTML page and executing any JavaScript code present. However, if the website is complex and the user's device needs more capabilities, it can strain the browser and become too much to handle. When it comes to bandwidth, as the server sends complete files to the client for each page request, it increases bandwidth usage. This becomes particularly significant when dealing with complex websites containing numerous pages and video and audio clips scattered throughout the website, and the initial page load time when compared to the latest technologies. This is due to the complete transfer of files for each request. Only after the server has sent all of the necessary files and the browser has finished parsing everything will we be able to view the website's content. Now, let's get a bit more modern. Let's talk about the React way. React helped to improve the development lifecycle by introducing components, virtual DOM, and the client and server mechanism. When you access a React website, the client's browser sends a request to the server for the website content. In response, the server sends a minimal HTML file, which serves as the entry point for the entire application along with a bundled JavaScript file. React initiates client-side rendering using this JavaScript file, manipulating the virtual DOM. Instead of directly modifying the actual DOM, React updates the virtual DOM and then applies only the necessary changes to the real DOM, resulting in the desired page display. React utilizes its client-side routing library, React Router, to navigate to different pages within the React application. This library enables changing the route without a full server request, preventing page refreshes. React Router re-renders the relevant components based on the new URL when a new route is triggered. If the new page requires fetching data from the server, the corresponding components initiate requests to retrieve the necessary data. Now, what's the catch with the React way? Why don't we stop there? Well, let's talk about complexity, processing, and SEO. Building a React application can present greater complexity than traditional HTML, CSS, and JavaScript websites. It involves thinking in components, managing state and props, and working with the virtual DOM, which may require a learning curve for developers new to React. Similar to the traditional approach, React primarily performs client-side rendering. It heavily relies on JavaScript for initial rendering and subsequent requests to update the user interface, which are all handled on the client's browser. However, this reliance on client-side rendering can delay rendering and interactivity, particularly on devices with slower processors and limited resources. And yes, if you recall, we previously touched upon a notable drawback of React when compared to Next.js in the introduction lecture. The issue is that search engine crawlers might not be able to fully access the website's content since everything is handled through JavaScript and only rendered on the client side. As a result, it impacts the website's visibility in search engine results. And finally, let's talk about the Next.js way, which is a blend of both. Knowing the benefits and limitations of both techniques, Vercel developers allowed us to choose where to render the content, on the client or on the server. Typically, when a user visits a Next.js site, the client sends the request to the server, which starts executing React components, generates HTML, CSS, and JavaScript files, and sends back the fully rendered HTML to the client as a response. This file includes initial content, fetch data, and React component markup, making the client render it immediately without waiting for JavaScript to download and execute. But it doesn't mean we don't receive any JavaScript files. The server will still send the JavaScript code as needed for the user interaction. From here, Next.js takes over and performs client-side hydration. Have you ever encountered the issue of a hydration error where the user interface doesn't match what was originally rendered on the server? Well, this is what it is about. Hydration is attaching JavaScript event handlers and interactivity to the pre-rendered HTML. And when the placeholders of React components, for example divs, forms, spans, don't match to what's being rendered on the client side, you can see that error. This is what it is, the hot topic of web development, SSR, server-side rendering. And for subsequent requests, you have full control over where to render your page content, either on the server side or on the client side. In the next lecture, we're going to talk about in depth about different types of server-side rendering along with client-side rendering and when and where to render what.